Hi there. If you're watching this, you are probably planning to retake the test from the other day. So this is one version of the test that we took. This is version 3. I don't know if you took this one or not, but all three were very similar. So what we'll do is we'll go over this, and this will be your pre-test for the test. You're not allowed to take that test until you complete this video and finish this pre-test. Make sure that you know how to do every section, because these sections are just like what's on the test. So don't go into it not knowing how to do a section, right? You know what sections are on there. This is how to do each section. Know how to do it before you take the test. Simple as that. Okay, so first section we have is just the generic balancing of equations. So when we do this, we always find something that's different on either end. In this case, we have 2 CLs on the right, and we have 1 CL on the left, so we need to fix that. I immediately go to balance the partner. That's 2 H's on the left. I already have 2 H's. 1 zinc and 1 zinc. It's balanced. Usually when you start these problems, start with the one with the most subscripts. That's usually the best bet. And if we look at this one right here, C10H16, that's unusual, so that's a good place to start. So let's start with those C's. We have 10 C's and 10 C's. 16 H's and 16 H's. Now, H has a partner, Cl, so we have to fix those Cl's too at the same time. So now we have 16 Cl's. We need to go back on this side. 2 times 8 is 16. Next problem. Probably the best one to start with is right here. It has the most subscripts. We have 2 ALs, 2 ALs. That gives me 6 OHs, 6 OHs. That gives me 6 H's. 3 times 2 is 6 H's, 3 SO4s, and I'm back where I started. Let's probably start with this thing. We have 4 P's. 2 times 2 is 4 P's. We have 10 O's. 5 times 2 is 10 O's. We probably will start with this. It doesn't make a difference on this one, really. That's 3 ammoniums. Put a 3 in front of that. That's 3 nitrates. We already have 3 nitrates. 1 aluminum, 1 phosphate, 1 phosphate. Last one. We have 2 F's, 2 F's, 2 K's, 2 K's. We're done. All right? That's the balancing equation section. It shouldn't be that difficult. Now, our next section is combustion. Now, when I do combustion, I do it the same every single time. I put a 2 in front of the C's and the H's. And then I balance the C's. So that's 2 times 4, that's 8 C's, 8 C's. That's 16 O's. Oh, no, I'm sorry, I'm going to wait to the O's for last. That's 18 H's times 2, so 18 times 2. Counting up my O's. 16 plus 18 equals 34. Divided by 2 is 17. 17 times 2 equals 34. Let's try the next one. We have 12 C's. 12 C's. We have 2 times 12. 12 times 2. That gives me 24 plus 12 equals 32, and that would give me 16 here. Now, they're all even numbers. So if it's all even numbers, I'm going to reduce those down. And I'm just going to reduce it down. So this is going to be 1, 8, 6, and 6. Next one. We have 2 times 6 C's. That's 12 C's, 12 C's. We have 14 times 2 H's. That's 14 times 2. And now we have 24, that's 12 times 2, plus 14 equals 38. Half of that is 19. We have 4 C's. We have 6 times 2, 2 times 6, Adding up our numbers, 8 plus 6 equals 14. Half of 14 is 7. Okay. All right, our next section. Now, this is from the dance thing, right? It's a pretty easy section. Nobody should miss these. So you're looking for things that are, you know, like the little dance lecture that we had, right? We have two couples and they're switching partners. That's a double replacement. We have two things joining together into one. That's a synthesis. We have one thing breaking apart into two. That's a decomposition. We have CHs. Look at that. That's combustion. And then we have a single cutting in, replacing one of the couple, and that's a single replacement. All right? You just have to memorize those. Look back at those notes on the dance thing. Watch that video if you're not sure what I'm doing. All right, on these you have to use the activity chart to see if they will react. Now the activity chart is the chart that has them listed. The top ones will replace the ones that were below it. So let's see here. I'll have to go back into my activity chart. I'm sure I have one right here. Oh, we've done a lot of notes since then. Here's my activity chart, my activity series. Okay, and so I wonder if I can do this. Nope. Okay. So what we have here is the activity series. You have to make sure you have that. Remember, the things on the top replace the things on the bottom. Let me erase these dots. We don't need those. Okay, let's go back. See what we have. Zinc. We're comparing zinc and lead. So is zinc above lead? That's what we need to look at. So let's go back. Oops, not that way. Let's go back. And activity chart is right here. And you look at that and you see that zinc is indeed above lead. Zinc is there, lead is there. So the one that is on the top can replace the one below it. Back to our notes. All right, so zinc is above lead, so it can replace it. So we have to react it. So zinc is going to take the place of lead. Okay, -1. So I put the charges above there like that. And then once I do that, then I crisscross my charges. Now, I don't really need to write a 1 there, but I'm going to do that just to show you. Okay. Plus, the PB got kicked out. Right? I don't really need to write a charge above the PB because it's by itself. There's nothing to crisscross with. Right? It's a good time to check your diatomics. Remember, there's 7 elements that are diatomics. Lead is not one of those, so it's fine. Okay, now we're going to balance. We have 2 acetates, right? 2 acetates on this side, and we have 2 acetates on that side. I think we're done already. It's all 1s. Yeah, everything's the same. So you can put 1s in, or the 1s are optional. Next thing on the chart, we're checking out aluminum compared to iron. So check your chart. Is aluminum above iron? I go back to my chart. I look. Let's erase what I had. And I look there, and there's aluminum. And there's iron. So aluminum is indeed above iron, so it does react. Okay, aluminum is above iron, so it can replace it. So Al, which is +3, ends up with the O, which is -2. Let's put a plus sign there. Okay, crisscross your charges, plus Fe. Okay, Fe is not diatomic, so we don't have to do anything with that. All right, let's look at our things here. So we have 2 Fe's on the left. Let's put a 2 in front of that. Oops, that's a weird thing that just happened there. We have 3 ALs. We already are 3 O's. We already have 3 O's, and we have 2 ALs, so we need a 2 in front of this, and it's done. You can put 1s in there if you'd like. All right? That's all there is to the first kind of single replacement. The next single replacements are the halogens. So this is where you have to use the bottom chart. Go back to your activity table. Oops, I pushed the wrong button. And you go down to the bottom, and it says halogens, and there they are. Right? And so fluorine, chlorine, bromine, iodine, in that order. And so we look here, it was fluorine, chlorine, bromine, iodine, right? So F is here, Br is here. Br is below F on the chart, so that's a no reaction. And just put no or no reaction. Right? And now we're looking at F and Cl on this next one. And F is indeed above Cl. So Na plus 1, F minus 1. Now, we can put our subscripts of 1 and 1, because, but that 1s are optional, right? Plus Cl. Now, is Cl diatomic? Yes, it is. So it needs a 2 behind it. Now we have to balance. We have 2 Cl's, 2 Cl's, 2 NA's, 2 NA's, 2 F's, 2 F's. We're done. All right, our next section is the acids. Oh, so you look on the chart. And acids are written in your chart. I highlighted mine in yellow when we talked about it in class. They're right there in yellow. So the top 3 sections will react with acids. Now let's look at those. Copper's right there. And copper was in that first one, right? So Cu is copper. I just unhighlighted it for some reason. It's right there. So it doesn't react with acid. I don't remember what the other one is off the top of my head. So we'll have to wait. Okay. So copper reacts with acid. So when copper reacts with acid, copper does not react with acid because copper was below it on the chart. So this is a no reaction. Zinc. Well, I know zinc's going to react. I'll show you where it's on the chart, though. So zinc is right here, way up here on the chart. Right? Zinc, and look, replaces the H in acid. So go back. Oh, I keep pushing that wrong button. So you go back to the problems here, and it's going to react with an acid. It's going to replace the H, so Zn plus 2. And then it's just a single replacement reaction, SO4 minus 2. So 2 and 2, we don't need any subscripts. So we can put 1s and 1s because they'll be reduced, right? And then plus H. Now you have to ask yourself, is H one of the diatomics? And the answer is, yes, it is. And so you need a 2 behind the H. All right. So balancing this equation, I think it's already balanced. It is. So we'll go on. All right. Reacting with water. So we have Fe, we have K, and we have Cu. Fe, K, Cu. Okay, so I'm trying to memorize those so I can do it all at one time on the chart. So let's go back to the chart. I know one already. Cu. Cu is way down here. So Cu does not react with water, right? Because the only ones that react with water are highlighted in blue. And they are, oops, now it's not highlighted in blue anymore, but they are reacting with water in the top 2 sections. The next one we had on there was Fe, and so Fe does react with water. But look how it reacts. It replaces the H, all of the H's in H2O, forming a metal oxide and H2. Let's do that before we go on. So, this is kind of weird here. I erased these on the other tests and I kind of messed up. I didn't erase them right here. Okay, so we have Fe is going to replace both H's. So Fe ends up with just the O. That's plus 3. That's minus 2. Don't forget to crisscross. Plus, it leaves the H's by itself. Is H diatomic? Yes, it is. Okay, now this needs balanced. We have 3 O's, 3 O's. 6 H's total. 3 times 2 is 6 H's. 2 Fe's, 2 Fe's. All right, this was a no reaction. Remember, we found that on the bottom. Okay, now we're to K and OH. Now K is in the top section of this chart, right? Way up here. So K is in the reacts with water section again, but this time it replaces just one H. So it makes a metal hydroxide. So and look at the reaction. We have example reactions on our paper. Let's go back and see if we can do it. So we have K, O, H. K is plus 1, OH is minus 1. No subscripts needed there. Plus H2. Is H diatomic? Why, yes it is. Put a 2 behind that. Let's balance. We have 2 H's. We have 1 H. Let's fix that. We have 2 OH's, 2 OH's, 2 K's, 2 K's, and we're done. Okay. Next section. Reacts with oxygen. The reacts with oxygen is the bottom 3 things on the chart. There's only 3 things that do not react with oxygen. They are silver, gold, and platinum. And look here. Silver and oxygen. No reaction. Right? So those bottom 3 on that chart, right? Everything else does. So we know that iron is going to react with oxygen. Now this is a synthesis reaction. So Fe plus O, or Fe and O. This is plus 2, this is minus 2. So they would be reduced down to 1 and 1. Now, we have to balance this. We have 2 O's, 2 O's, 2 Fe's, 2 Fe's. All right, and that's that. In the last section, we're going to use this time our precipitation chart, our solubility chart when we're done. Well, let's balance the equations first. These are double replacement, so we have to switch the partners. Oops, sorry about that. So K goes with the NO3, right? The positive goes with the other negative. They're just switching partners. The Ag goes with the I. Plus 1, minus 1. So we don't need any subscripts in this one because they're plus 1 and minus 1. And because of that, there's nothing different, so it's all balanced out. All right, I'll balance the other one first, and then I'll go back and open up that solubility chart. So we have Ca is going to be with the OH. Ca is plus 2, OH is minus 1. We needed 2 there. Plus Na plus 1 goes with the Cl, which is minus 1. Right? So what happens is they are 1 and 1. They don't really need subscripts. But because we have that 2 there for the OH, we have to balance. 2 OHs, 2 OHs, 2 NAs, 2 NAs, 2 CLs. We already have 2 CLs, so we can throw 1 in there or leave it like it is. Okay, now let's circle our precipitates. Now the rule for precipitates. Let me go back to the chart. The shortcut. The thing that's going to make it the easiest to do is look at the top. Where's that chart? Oh, that's right. I switched them around this year. I did it first. I usually do the activity series and the solubility chart second. That's why it's that order on the test. But this year, because I wanted to do that lab that one day, I switched it around so we could have the single replacements before we did the single replacement lab. Okay, so let's look at this chart. Now, I like to look at this first section of this chart first, because all alkali ions, LiNAK, Rb, Cs, and Fr, are soluble every time. So if we look at that first, that eliminates usually one of these things in the problem. Let's go back and look. So if we look right here, there's a K. Okay, so that is soluble. We're not going to circle that one. And this is Na. So that one's soluble. So right off the bat, just by looking at that top section, you know that those two cannot possibly be the precipitate. Let's check out the other ones, because sometimes Mr. Arnold has a no precipitation at all in the equation. So let's look up silver iodide. Silver iodide, way down here. They're getting a little fired up upstairs. I don't know if you can hear them, but okay. So here's I have it highlighted already. This is one we did in class, everybody. So there's iodide right there, right? And there's silver. So we just match it over here and see what it says. Low solubility. So when it hits low solubility, I have that circled because that's the one that was going to be the precipitate. And so I'll go back and I will circle the silver iodide. So this one right here is our precipitate. Calcium hydroxide. Let's go check the other one out here real quick. Calcium hydroxide. Calcium hydroxide. Okay. Let's see. Where's the hydroxides? Here they are. So let me erase the one we're not using. And here's the hydroxides. So only the usual suspects in strontium, right? The alkali ions, the H plus, the Na, the NH4, and Sr plus 2 are the only things that are soluble. All others, which calcium is part of that group, would be low solubility, which means it would be the precipitate. And I'll go back and I will circle this, and voila, we did it. 100% on that test. All right, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9 different sections on this test. Just know how to do each section and you'll do fine. If you don't know what you're doing when you get in these sections, you're not going to be able to do it, right? You can't fake this. You can't fake finishing the reactions. It just doesn't work. There's too many steps. There's too many things. So that's that. Now, that's the pretest, and this is the video you have to watch. I'm going to make you have to do this, so you have to watch the video. We have a lot of people who are just skimming these videos, and you're missing out on the important things, and you just copy answers down. Well, guess what? It comes test time. That comes out. We see it. We know it. All right? You can't fake it. You have to learn how to do this stuff. It doesn't go away. You already know that because we're in the next section already, and we have to use these balanced equations. Okay, well, that's it for this. The test will be posted. It'll be one of those things where you have to do it in order. So if you tried to open the test and it wouldn't open for you, it's because you couldn't do it until after you finished these other assignments. All right, thank you, and good luck.